Welcome back to the Cave of Science, and we're going to look at today some naming ionic compounds and then writing the formulas from ionic compounds. If you remember from previous videos, when we have ionic compounds, the cation or the metal, you just name the metal. If it has more than one charge, you put whatever charge it happens to have in Roman numerals in parentheses. And then the anion, if it is a single element or binary compound, it's an IDE ending. If it's a polyatomic ion, you would name the polyatomic ion. So let's go ahead and get started on some of these. So we got NaBr, so that's sodium. So sodium. Br is bromine, so it would go to the IDE ending. So it would be bromide. Okay, the next one, the metal would be calcium. And the nonmetal is oxygen, and that would go to oxide. Number 3, Li is lithium. And the S is sulfur, and that goes to sulfide. Number 4, Mg is magnesium. Br again is bromine, so it would go to bromide. Number 5 is a little unusual. Pu is plutonium, and it works the same way as the other ones. So we have plutonium, and OH is a polyatomic ion, which is hydroxide. On to number 6, Hg is mercury. Cn is a polyatomic ion, and that's cyanide. Going on to the next one, Mo is something you don't see real often, but that's molybdenum. Let's see if I can spell this right. Molybdenum. And C2H3O2 is the polyatomic ion acetate. Again, probably a compound you wouldn't see a whole lot of. Number 8, Cr is chromium. And CrO4, that happens to be chromate, a polyatomic ion. All right, WO is another one you don't see a whole lot of, and that is tungsten. And O2 would be oxygen or oxide. Mg is magnesium. And ClO is chlorite, another polyatomic ion. We should go back and look at the mercury with a cyanide. Technically, and you're not going to see it that often, but mercury would be mercury 1. Well, actually, this one would be mercury 2 because there's 2 cyanides. So we could have that. You don't see it too often, but that would actually be mercury 2 with the Roman numeral 2. You don't see that real often. All right. think all the other ones look pretty good. Other ones, if we had something with iron or lead, they would have different charges associated with them, where we use the Roman numeral. Let's see if we can go the other way with this one. So instead of writing the name, let's take the name and go to the formulas. So a little bit different play. Now, on this one, when you write them down, then you got to balance for charges also. So this one there's one more step involved here. So let's go with potassium. That's K. That has a +1 charge. And Cr2O7 is the dichromate. So that would be Cr2O7 is the dichromate, and that has a -2 charge. So now to write the appropriate formula, you would swap and drop. So the coefficients would swap places, crisscross if you will. So this would be K2Cr2O7. So that would be the correct formula for potassium chromate. I'm going to do the rest of these, kind of start doing below and above a little bit so we can see what's happening on these. So let's look at gold 3 oxide. So gold, if you remember right, let's see if we can get a little room here. So gold is Au, and it's a Roman numeral 3, so you know it's got a +3 charge. All right, oxide would be O, and that has a -2 charge. So if we swap and drop or crisscross, we have Au2 plus O3. So this would be a +3 charge, this would be a -2. 2 times +3 is a +6, -6, so that's going to equal 0, because they have to be electrically neutral. So when you swap and drop, you're just taking the charges and making them the subscripts. Let's look at the next one, aluminum. Give ourselves a little room here. And aluminum, if you remember right, has a +3 charge. Periodate has its IO4, has a -1 charge. So we'll swap and drop. So we have aluminum, and then IO4. And if there's more than one polyatomic ion, it has to be in parentheses. So we have 3 on there. Let's look at the next one. Get this one done. So barium nitrate. Barium has a +2. Nitrite is NO2 with a -1 charge. Go back to your chart of polyatomic ions on those. So again, we would do the swap and drop here. So we'd have barium, and we need 2 of the nitrite ions. So NO2, 2. And again, 1 times the +2 is 2. 2 times the -1 is -2, and that would equal 0. All right. Moving on down, let's do silver carbonate. Silver is Ag and has a +1 charge. Carbonate, CO3 with a -2. So we could do our swap and drop. So we have Ag2CO3, silver carbonate. All right, let's go on down to the next one. Lithium is Li with a +1 charge. And then sulfite. Sulfite would be the polyatomic ion SO3, and that has a -2 charge. So if we do the crisscross, we end up with Li2SO3, lithium sulfide. All right, we'll flip it around, go the opposite way now. Zinc hydrogen carbonate. So zinc has a +2 charge. Hydrogen carbonate is HCO, and that has a -1 charge. You can find that typically on your polyatomic ion sheets. So we could do the crisscross. So zinc, and we have to have 2 of that polyatomic ion. All right, got this one done. 18, iron 3, so it's telling us this iron has a +3 charge. So iron +3, and then hydroxide is a -1. So if we swap crisscross, we have FeOH3. Now remember, if you got more than one polyatomic ion, it has to go in parentheses. Next one is ammonium, and that's the only positive polyatomic ion. It has a +1 charge, and that is combined with phosphate, another polyatomic ion. But this one has a -3 charge, so we could play the same rules here. So ammonium, NH4, and the same rule holds. If there's more than one of a polyatomic ion, put in parentheses, and then PO4. So we got ammonium phosphate, and the last one we have is copper 1, so copper plus, and bromite, BrO2, and that, it's copper +2, so it's +2 charge. Bromite is BrO2 with a -1, so we have copper BrO2, and we need 2 of those to balance it out. So that's how you would run those. And again, if you have your polyatomic ion sheets, periodic table, you can get most of the charges. So remember, for ionic compounds, name the metal, and then the non-metal. If it's a binary one, we'll go to IDE. If you have a polyatomic ion, you name the polyatomic ion. So, till next time.